Sometimes it'll be necessary to take a vector that's not a unit vector, meaning that it's longer than length 1 or shorter than length 1, and write it as a unit vector, which means scale it either to be shorter or longer than it currently is to where it only has length 1. This process is called normalizing a vector. So that's what that means. If you hear that word or somebody ask you to normalize a vector, that's what they're asking you to do. So graphically it looks something like this. If this is, let's say a vector, we'll call it V, and let's say it's much longer than a unit vector. What we want to do is find a vector that's in this guy's same direction that's only about this long, meaning that shorter vector is a unit vector of length 1. So now how do we do this? Like if I actually handed you a vector, how would you turn it into a unit vector? How would you normalize it? Well, there's a little formula, and you probably want to commit this guy to memory. To get your unit vector, you're going to take your old vector and divide it by whatever its own magnitude is. So for example, if this long vector had a length of 5, you would divide all the components of V by 5. And what that does is it scales the vector back without changing the direction and makes it a unit vector. So let's wrap up this video with a quick example. Here we've got a vector, we'll call it 4, -9. So it goes right 4 and down 9 in component form. And obviously that guy's much longer than a unit vector. So how would you find a vector that's much, much shorter than this guy that goes in the same direction as V? Well, we're going to use that formula. The first thing we actually need, though, is the magnitude of V, because that's part of the formula. We need to know how long V actually is. And so we know how to find the magnitude of a vector. We'll take the first component squared, which is 16, plus the second component squared, which is +81. We'll add those two guys. We'll get the square root of 97. And I don't think that really simplifies, so we'll just leave it like that. Okay, and that's the length of V. That's 9 point something. That's almost a length of 10. That's way too long. So to get our vector, our unit vector, we'll call it vector U, we're going to take the vector 4, -9, and we're going to divide all of its components by root 97. Now you can either write this over root 97, which is okay, that's not bad, but a lot of times, just to conserve space and just to help it make a little bit more sense, sometimes I'll write 1 over root 97 out front, because again, that's just like dividing by root 97, but that way it's written more like a scalar times a vector or scalar multiplication. And then we're just going to distribute this guy through, and our final answer for vector U would be 4 over root 97, -9 over root 97. That seems a little weird, but these unit vectors often look this way. They often look a little crazy. I'm not going to do it in this video, but I'd encourage you to try it right now at your desk. Try taking the magnitude of U, this new guy that we got right here, and just see if you get the number 1. And I'll bet that you do. This guy should be a unit vector. It's a vector in the same direction as V, but it only has a magnitude of 1.